drop an anchor from a ship, right? Yeah. And you expect it to hit the seafloor.
Yeah, you expect some kind of solid ground.
Exactly. The heavy iron goes over the side, the chain rattles down into the dark water, and eventually the anchor catches.
Yeah.
You have a fact. It's solid bedrock. You can build a map around it.
Right.
In classical physics, and frankly just in our everyday lives, that is exactly how we expect physical reality to work. The universe has a state, a definitive configuration of matter and energy, and that state just is. It's absolute.
It's comforting, honestly.
It really is. But the moment you step into the philosophical frameworks trying to make sense of quantum mechanics, well, that anchor chain just keeps unspooling. The water goes down forever.
Yeah, it really does.
You find yourself looking at a physical landscape that is terrifyingly groundless. It's an ontological abyss where the seafloor simply does not exist.
And, that lack of bedrock isn't just a poetic metaphor. It is a rigorous mathematical consequence depending on how you interpret the quantum formalism.
Right. Which brings us to today's deep dive. We are exploring a framework that embraces that abyss completely. Relational Quantum Mechanics, or RQM.
Pioneered by the physicist Carlo Rovelli.
Exactly. But since you are an expert-level learner, we aren't just doing a surface-level summary of RQM here. We're delivering a deeply analytical commentary for experts.
Yeah, we're getting into the metaphysical plumbing today.
We really are. We're unpacking a highly specialized 2024 paper by the philosopher Timotheus Riedel. It was published in Studies in History and Philosophy of Science. The title is Relational Quantum Mechanics, Quantum Relativism, and the Iteration of Relativity.
It's a dense read, but a brilliant one. Riedel takes the internal logic of RQM and just subjects it to extreme pressure.
He specifically targets a hidden philosophical trap inside it called the unrestricted iteration principle, right?
That's the one. And it's a trap where quantum physics bleeds directly into metaphysics, basically challenging our basic assumptions about what it means for something to be mathematically or physically true.
Okay, let's unpack this. Because to understand why Rovelli threw the concept of an absolute universe out the window in the first place, we have to look at the crisis that pushed him to do it.
We have to start with Wigner's friend.
Right. The Wigner's friend dilemma. Now, if you're listening to this deep dive, you're likely already familiar with the basic contours of Wigner's friend. It's that classic 1961 thought experiment by Eugene Wigner.
Extending the Schrödinger's cat paradox to human observers, yeah.
Exactly. But we need to drill down into the specific mathematical friction of this paradox. Yeah. Because that friction is the literal engine for everything Rovelli built.
Yeah, the friction lies entirely in the conflict between unitary evolution and the collapse postulate.
Let's set the parameters precisely for the listener.
Sure. So we have a perfectly isolated laboratory. Absolutely no information, heat, or stray photons leak out. Inside is the friend.
And the friend is going to measure a simple quantum system, right?
Right. Say the spin of a silver atom along the z-axis. The atom starts in a superposition of spin up and spin down. The friend measures it, the detector flashes, and for the friend, the wave function has collapsed. She has a definite, concrete result. The spin is up.
Anchor dropped. The friend has a fact.
Exactly. But standing outside this perfectly isolated laboratory is Wigner.
And Wigner has a problem.
A big one. Because the lab is isolated, Wigner must treat the entire room, the atom, the detector, the air molecules, and the friend herself, as a single, massive quantum system.
Because standard quantum mechanics demands it.
Right. According to the foundational rules, specifically the Schrödinger equation, an isolated system evolves deterministically and smoothly. This is unitary evolution.
So for Wigner, there is no collapse.
None. For Wigner, the measurement inside the lab didn't cause a collapse, it caused an entanglement. The superposition of the atom infected the detector and then infected the friend.
Wow.
So Wigner describes a state where the friend is in a macroscopic superposition of having measured up and having measured down simultaneously.
So it's not like the friend flipped a coin and Wigner just doesn't know the result.
No, not at all.
The natural classical instinct here is to look for a loophole. To say that Wigner's math is just a reflection of his own personal ignorance.
Right.
The coin landed on heads, and Wigner simply doesn't know the outcome yet. He's just using the superposition math as a placeholder for probability.
Yeah, that instinct is what we call an ignorance interpretation. You're treating Wigner's state as a proper mixture. But, as Riedel points out in the paper, citing the physicist Bernard d'Espagnat all the way back in 1966, standard quantum mechanics strictly forbids Wigner from treating this as a simple case of ignorance.
Walk us through why. Why can't Wigner just say, she has the fact, I just lack the data?
Because the mathematical object Wigner uses to describe the lab, a pure state density matrix, contains off-diagonal elements.
Buff diagonal elements, meaning interference.
Exactly. Those elements represent actual quantum interference between the two branches of reality, the friend saw up branch and the friend saw down branch.
Okay.
If Wigner were to assume the lab was in a definite but unknown state, those off-diagonal interference terms would just vanish. The math would change into a mixed state.
Right, which changes the predictions.
Crucially, yes. That pure state, with its interference terms, has testable physical consequences.
Meaning Wigner could theoretically design an experiment to prove the superposition is real.
Precisely. Wigner could, in principle, perform a highly complex measurement on the entire laboratory. He could recombine the two branches of the macroscopic wave function and measure an interference pattern.
Which is mind-blowing.
It is, because if the friend actually had a definite, absolute fact inside that room, that interference pattern would be physically impossible to produce.
Wow.
Therefore, Wigner's description of the lab as a genuine superposition must be considered physically correct and complete because it predicts phenomena that an ignorance model would completely fail to predict.
The coin is literally still spinning for Wigner while lying flat for the friend.
That is exactly what the math says.
So Wigner's math is correct, and he has interference to prove it. But the friend's experience is also correct, because she's staring right at a detector that says, up. Standard quantum mechanics is basically allowing two mutually exclusive realities to be completely true at the same time.
Yeah, it's a massive contradiction.
I mean, how can physics survive if two observers have entirely different facts? Reality cannot contain a contradiction.
Carlo Rovelli stepped into this exact conceptual wreckage in 1996 and proposed his radical solution.
Relational quantum mechanics.
Yes, he argued that the paradox is entirely an artifact of our own stubborn philosophical assumptions. We are demanding a view from nowhere.
A master spreadsheet.
Exactly. We demand a master spreadsheet of the universe where every variable has a single, definitive, absolute value. Rovelli's solution was to declare that this master spreadsheet simply does not exist.
He just burns the spreadsheet.
Burns it to the ground. He proposed that all state-dependent properties like spin, position, momentum are invariably relative to a specific reference system.
So the atom is spin-up relative to the friend.
Right.
And the atom and the friend are in a massive entangled superposition relative to Wigner.
Exactly. Both statements are mathematically complete, and crucially, they are completely non-contradictory because they are indexed to entirely different observers.
By shattering the universe into a web of relative realities, RQM completely dissolves the Wigner's friend paradox. You no longer have two observers arguing over the true state of the system.
Because the true absolute state is a meaningless concept now.
That elegantly solves the math problem, sure, but it triggers an absolute avalanche of physical and metaphysical questions.
Well, absolutely does.
If properties are only relative to the system observing them, we have to redefine the mechanics of the entire universe. I mean, if a tree falls in a forest and no one is there, what is it falling relative to? We need to lay out the ontology of what we'll call classical RQM Rovelli's framework from 1996 up through roughly 2022.
Let's do it.
What actually exists in this framework and what qualifies as an observer?
Well, in classical RQM, the concept of an observer is entirely stripped of any mystical or anthropocentric baggage.
Right, no human consciousness required.
Consciousness is totally irrelevant. A reference system or an observer can be a human physicist, yes, but it can also be a single qubit, a stray photon, a Geiger counter, or a milkshake sitting on a counter.
A milkshake, I love that.
Any physical system can act as a reference system for any other physical system.
I love the milkshake example because it radically democratizes quantum mechanics.
Mm-hmm.
You don't need a PhD student in a white coat to collapse a wave function.
No white coat needed.
If a photon flying through a diner bumps into a milkshake, that photon acquires a definite relative position. It actualizes a property relative to the milkshake. The universe is just a dense, chaotic web of physical systems colliding into one another, exchanging relative facts.
But the truly radical part of the ontology is what happens between those collisions.
Right, when they aren't interacting.
In classical RQM, properties do not exist in a vacuum. A property only actualizes, it only becomes real during a physical interaction. Between interactions, systems simply do not possess determinate properties.
They just don't have them at all.
No. Ravelli describes physical reality not as a smooth, continuous evolution of matter moving through space, but as a very fine-grained but discrete swarming of flash-like events.
A strobe light universe.
Exactly, a strobe light universe. When two systems interact, there's a flash. A property actualizes relative to those two systems.
And then?
Then the systems decouple, and they plunge back into an indeterminate state of relative potential until their next interaction.
That defies every physical intuition we have. I mean, when I throw a baseball, I assume it has a continuous position at every millimeter of its arc between my hand and the catcher's mitt.
Of course you do. That's classical thinking.
But RQM is saying it only has a relative position when it hits the air molecules, or when the stadium lights bounce off it, or when it hits the leather of the mitt.
If we connect this to the bigger picture, Ravelli defends this highly counterintuitive ontology by tracing it directly back to the philosophical origins of quantum mechanics itself.
Back to Heisenberg.
Right. He argues that this flash-like reality is the ultimate realization of Werner Heisenberg's original logic.
Matrix mechanics.
Yes. When Heisenberg formulated matrix mechanics in the 1920s, his radical breakthrough was a philosophical refusal. He refused to invent properties for the electron when it wasn't being looked at or interacted with.
You just wouldn't do it.
He discarded the idea of continuous unobservable orbits and focused only on the observable quantities exchanged during emission or absorption. RQM takes Heisenberg's operationalism and applies it universally to the entire fabric of reality.
Okay, but if the universe is just this sparse, discrete swarm of flashes, where does the wave function fit in?
That's the big question.
We use the Schrödinger equation to predict things with incredible accuracy. We treat the wave function as if it's a real thing undulating through space. What is it in Ravelli's framework?
It is strictly an epistemic bookkeeping device.
Epistemic. So about knowledge.
Yes. In classical RQM, the quantum wave function is completely stripped of physical reality. It is not a real wave of energy. It is not a physical field.
Okay.
It is simply a mathematical algorithm that one specific system uses to calculate the probabilities of future interactions, based entirely on the history of past interactions it has experienced.
So when Wigner writes down his massive wave function for the entire laboratory, he isn't describing the physical room.
Not at all.
He's just updating his personal probability algorithm for what he might see if he opens the door.
Exactly. And that deflationary view of the wave function is arguably RQM's greatest strength.
Why is that?
Because it elegantly resolves the problem of quantum non-locality, what Einstein called spooky action at a distance.
Right, the faster-than-light problem.
If the wave function isn't a real physical object extending across galaxies, then when a measurement happens, there is no real physical way that has to instantly collapse faster than the speed of light.
Oh, I see.
The collapse is just you, locally, updating your bookkeeping based on a new flash of interaction. Nothing travels faster than light because nothing physical is actually collapsing.
Okay, the mechanics of this are really starting to lock into place. We have point-like interactions where properties momentarily flare into existence, strictly relative to the systems involved, and wave functions are just local prediction engines.
That's the core of it.
But this brings us to a glaring practical roadblock. Science, by definition, requires intersubjective agreement.
It definitely does.
If properties are only relative to the system you personally bump into, how do multiple observers ever agree on the facts? How does Wigner ever find out what his friends saw inside the lab without breaking the rules of the theory?
This brings us directly to the core of Timotheus Riedel's critique. To explain how observers agree, RQM relies on a mechanism called the unrestricted iteration principle, or UIP.
UIP. Okay, let's walk through how Wigner actually queries his friend under UIP.
So Wigner cannot just passively know the friend's result. He must physically interact with the composite system of the friend and the particle.
He has to open the lab door.
Right. He opens the lab door, walks in, and asks her, "What did you see?"
Light bounces off the friend's notebook. Sound waves from her vocal cords hit Wigner's eardrums. A physical interaction takes place. A new flash.
Yes. Wigner's physical variables, the neurons firing in his brain, become correlated with the friend's variables. Wigner now holds a piece of information. The friend saw spin-up.
Okay.
Here is the trap. Because this is RQM, all state-dependent properties are relative to the observing system. Therefore, Wigner's new knowledge is not an absolute fact about the universe.
It's not.
No. The fact that the friend saw spin-up is itself a relative fact. It is only a fact relative to Wigner.
Let me make sure I'm mapping this correctly. The friend measuring the atom was a fact relative to the friend.
Yes.
Wigner later asking the friend what she saw is a fundamentally separate event, and the answer he gets is only a fact relative to Wigner.
That is the unrestricted iteration principle in action. There is no absolute transcendent fact about what the atom did relative to the friend. The event of the friend's measurement only becomes real for Wigner when he interacts with her.
Wow.
And Riedel points out that Ravelli deliberately engineered the second-order relativity as a theoretical shield.
A shield to protect the theory from what?
From the very contradictions that made Wigner's friend a paradox in the first place. Think about it. If there were an absolute objective fact about what the friend saw, Wigner's subsequent unitary measurements could potentially contradict it. But RQM neutralizes that threat by making the comparison itself a relative event.
So you can't even compare notes objectively.
Right. Ravelli argues that asking, do Wigner and the friend get the same answer, is an ill-posed pseudo-question. It implicitly smuggles in the concept of a view from nowhere.
The spreadsheet again.
Exactly. You cannot ask if they fundamentally agree in the absolute. You can only ask if they agree relative to Wigner or relative to a third observer.
Here's where it gets really interesting. Once you introduce a third observer, you trigger the infinite regress.
Yep, down the rabbit hole.
If Wigner's observation of the friend's notebook is strictly relative to Wigner, what happens when observer 3, standing outside Wigner's office, asks Wigner what the friend saw?
Observer 3 interacts with Wigner. A flash occurs. Observer 3 now possesses the fact. Wigner heard that the friend saw spin-up. But according to the iteration principle, this is merely property X relative to the friend, relative to Wigner, relative to observer 3.
And observer 4 asks observer 3. Observer 5 asks observer 4. It's an endless chain.
Turtles all the way down.
We are standing in a quantum hall of mirrors. You look into the glass, but you aren't seeing the true reflection of the room.
Yeah.
You're seeing a reflection of a reflection of a reflection, scaling backward infinitely. And the genuinely unsettling part of RQM's ontology is that there is no original object casting the reflection.
That's the scariest part, metaphysically.
The mirrors themselves are the entire reality.
The unrestricted iteration principle dictates that you never ever hit an absolute level. Every statement about a physical state is relative to another system, infinitely.
There's no bottom.
There is no mathematical or conceptual mechanism for regaining an absolutely valid statement by specifying ever more relata. If you accept classical RQM, Riedel argues, you must swallow this infinite regress of relativizations whole.
But let's bring this back to the practice of actual physics. I mean, if every single measurement I make requires an infinite sequence of reference systems to validate it, how does a physicist ever publish a paper?
It becomes a logistical nightmare.
Right. If a scientist can only state, the thermometer reads 72 degrees relative to me, relative to the equipment, relative to the peer reviewer, the scientific method kind of drowns in the regress. The sheer vertigo of this principle must have caught up with Ravelli eventually.
It did, and it resulted in a massive, highly controversial fracture within the RQM community.
Really? When was this?
Recently. The theoretical vertigo of the iteration principle led to a fork in the road. In 2023, Emily Adlam, a physicist and philosopher, collaborated directly with Carlo Rovelli to publish an updated, modified version of RQM.
Okay, an update.
They introduced a concept called cross-perspective links, or CPL.
Let's investigate this 2023 update because introducing a patch to a theory this fundamental usually implies the core was structurally unsound. What exactly did these cross-perspective links do?
They represent a profound retreat from the radical relativism of 1996. The 2023 update proposes that the point-like quantum events, the flashes of interaction, are actually absolute, observer-independent facts.
Wait.
Yeah.
The fundamental mantra of RQM was that there is no view from nowhere. Absolute facts don't exist. That was the entire basis for solving Wigner's friend.
The cross-perspective links walk that back explicitly. Adlam and Rovelli introduced a postulate that allows for absolute comparisons between perspectives. It effectively states, if Alice measures a quantum variable, and Bob later measures Alice's physical variables that store the information about her measurement, Bob's result will absolutely, unequivocally match Alice's result.
To bring back our earlier analogy, if classical RQM is a massive spreadsheet where every entry has an infinite chain of relative to columns, the 2023 update essentially hard codes a macro into the software.
That's a great way to put it.
It forces Bob's cell to automatically sync with Alice's cell. It stops the Hall of Mirrors instantly.
That is the exact function of CPL. The occurrence of an interaction between two systems is elevated to an absolute universal truth. You no longer need observer 3, 4, and 5 to validate the correlation.
Right.
Bob's measurement result will match Alice's measurement result in an absolute sense, anchoring the theory back into a somewhat recognizable classical reality.
But doesn't that sort of lobotomize the theory? You invent a mathematical rule to stop the infinite regress, but in doing so, you gut the specific relativistic elegance that made RQM revolutionary in the first place.
Riedel is scathing in his critique of this exact pivot. By introducing cross-perspective links, RQM suffers a severe derelationalizing,
Derelationalizing.
a term echoed by philosophers like Bos van Frassen. But the cost is much higher than mere aesthetic elegance. By making interactions absolute, RQM loses its strongest, most compelling justification for existing in modern physics.
Which goes back to Wigner's friend, right?
Specifically to the modern, hyper-advanced versions of Wigner's friend. In recent years, quantum relativism surged in popularity due to a series of rigorous mathematical proofs known as Bell-Wigner mashups, or no-go theorems.
Right, the new paradoxes.
Physicists like Bruckner, Frackager, and Renner designed incredibly complex thought experiments. Imagine 4 observers, 2 separate isolated laboratories, and systems of entangled particles being measured inside and outside the labs simultaneously.
It's Wigner's friend applied to Bell's theorem.
Exactly. And these theorems prove mathematically that if you hold on to 3 basic assumptions, that quantum mechanics applies universally at all scales, that there is only one single world, and that observer-independent measurement outcomes exist, you will inevitably derive logical contradictions.
So the math just breaks.
Observers in these mashups end up proving statements like, I am certain you measured spin up, but I also measured spin down.
Standard quantum mechanics just crumbles under the weight of these mashups.
But classical RQM was the perfect shining armor against these no-go theorems.
Because it rejected the premise.
Yes. RQM looked at the Frauke-Renner paradox and simply said, we reject the assumption that observer-independent measurement outcomes exist. Everything is relative, paradox solved. It was the ultimate trump card.
But if the 2023 Adlam and Rovelli update explicitly declares that the flashes of interaction are observer-independent outcomes,
And then they actively revalidate the premises that lead to the paradox. Emily Adlam acknowledges this, by the way. Yeah, she argues that the updated CPL version circumvents the theorems by rejecting a different, highly technical mathematical premise regarding how joint probabilities are calculated.
Okay, shifting the goalposts a bit.
But Riedel's point is devastating. If you do that, you can no longer point to the Wigner's friend no-go theorems as the definitive proof that physics demands relational quantum mechanics. With CPL, RQM is just another standard interpretation, awkwardly tweaking mathematical rules to survive a paradox. It surrenders its inevitability.
It trades its philosophical soul for a bit of mathematical stability.
Precisely.
So this leaves us at a fascinating crossroad. If the 2023 update is a compromised off-ramp, what happens if we stay on the highway? What if we insist on defending the pure, unadulterated classical RQM from 1996? We keep the infinite regress, we keep the unrestricted iteration principle, and we see if the underlying logic actually holds up.
If we choose to ride the infinite regress down to the bottom, the equations of physics can no longer guide us. We are entering the domain of hardcore metaphysics.
Bring it on.
We have to analyze the fundamental architecture of what classical RQM claims a fact is. To do this, Riedel introduces a philosophical distinction that goes entirely unnoticed by most working physicists. We must differentiate between relationalism and perspectivism.
Those sound like synonyms to a layperson. Relationalism. Perspectivism. In the context of quantum mechanics, what is the actual wedge between them?
The wedge is found in the linguistic and metaphysical structure of properties. Let's start with relationalism.
Okay.
This is the intuitive folk way we handle relative concepts in our everyday lives. In philosophical terms, relationalism is a view that alters the adicity of a property.
Adicity. That refers to the number of arguments or parameters that a property requires to be complete, correct? Like slots in a sentence.
Exactly. Take a simple classical statement. The car moves at 50 kilometers per hour.
Okay.
A non-relativist views that sentence as a complete monadic property. It has one slot, the car. The car possesses the absolute property of velocity. But since Einstein, we know velocity is relative. The relationalist steps in and says, that sentence is grammatically incomplete. It is shorthand. The property of velocity has a higher adicity. It has 2 slots. The true, complete fact is, the car moves at 50 kilometers per hour relative to me.
You fill the second slot, and the sentence is complete.
And this is the crucial defining feature of relationalism. Once all the slots are filled, once all the relatas are specified, the resulting fact is an absolute fact.
Wait, absolute?
Yes, it is an objective, universal truth that the car is moving 50 kilometers per hour relative to you. Any observer anywhere in the cosmos can look at your reference frame and agree on that absolute relational fact.
Yeah.
For the relationalist, reality is still one single giant master spreadsheet. It's just that the entries require relative to columns to be properly formatted.
So relationalism preserves an absolute reality, just with more complex grammar. What does perspectivism do differently?
Perspectivism, specifically realism about perspectival facts, refuses to change the adicity of the property. The perspectivist looks at the sentence, the car moves at 50 kilometers per hour, and says, that is a literal, complete fact. It has 1 slot. It is not shorthand.
But how does that account for relativity? If I'm driving next to the car at the same speed, its velocity is 0.
What's fascinating here is that the relativity doesn't live inside the grammar of the fact. The relativity lives in the mechanism of how the fact becomes true.
I see.
The perspectivist says, the car moves at 50 kilometers per hour is a complete fact that becomes real strictly from one specific vantage point. From your vantage point driving next to it, the complete fact the car is stationary obtains.
Under perspectivism, we aren't sharing a master spreadsheet with extra columns. We each have our own completely separate clipboards.
Perfect analogy, yes.
Reality itself is fractured by vantage points. The facts on my clipboard literally exist, and the facts on your clipboard literally exist, even if they contradict each other globally.
That is the radical nature of perspectivism. Now, the friction arises because physicists, when dealing with quantum relativism, almost universally default to relationalism.
Because it's safer.
It feels safer. It preserves a sense of absolute truth. Carlo Rovelli is the prime example. I mean, he named his theory Relational Quantum Mechanics.
Right.
In his foundational texts, he constantly utilizes relationalist language. He writes that quantum properties are dyadic relations. He says that contingent properties refer to 2 systems, not one. He is explicitly filling the adicity slots.
Rovelli wants the master spreadsheet. He wants relationalism. But wait, if Rovelli's framework relies on relationalism, how does that survive contact with the unrestricted iteration principle? The iteration principle says the chain of observers never ends. You can never fill all the slots.
You have just sprung Riedel's trap. This is the metaphysical disaster at the heart of the paper. Riedel provides a devastating logical proof that combining relationalism with the unrestricted iteration principle destroys the theory from the inside out.
Walk us through the proof. How does the universe go blank?
It proceeds in simple, unavoidable steps. Premise 1, relationalism dictates that a fact is only valid, true, and complete once all of its relative to slots are filled. There are no perspective-dependent facts. There are only absolute relational facts.
So to state a true fact about the atom spin, you must list every relata. The atom is spin up relative to the friend, relative to Wigner, relative to observer 3, and so on.
Right. Premise 2. The unrestricted iteration principle dictates that the chain of relativization is infinite. Every statement about a state-dependent property is relative to another system, endlessly. You can never reach the end of the chain.
Which means the slots are infinite. You can never finish writing the sentence.
Exactly. Conclusion. If relationalism requires you to fill all the slots to produce a fact, and the iteration principle makes it logically impossible to fill all the slots, the inevitable result is that nothing is the case at all.
The facts literally cannot materialize.
Exactly. There are no state-dependent properties anywhere in the universe. If you try to read classical RQM as a relationalist theory, you are logically forced to conclude that the universe contains 0 physical properties.
No mass, no spin.
No position, no velocity. Because to possess even a single property, a system would have to complete an infinite sequence of relations, which is mathematically and logically impossible.
It's like arguing that a legal contract is only binding if it is co-signed by a manager.
Good analogy.
But corporate policy dictates that every manager needs their superior to co-sign, scaling up infinitely. Because you can never reach a final CEO to provide the absolute final signature, the contract never actually executes. The universe just fails to boot up.
Riedel's proof is undeniable. Classical RQM, with its infinite regress, cannot be given a sensible relationalist reading. If Ravelli wants to keep the iteration principle to protect his solution to Wigner's friend, he has to throw relationalism overboard. He has to abandon the master spreadsheet.
He has to embrace perspectivism. He has to accept that the universe is just a chaotic pile of isolated clipboards where facts simply obtain from local perspectives and nowhere else. So, does jumping into the lifeboat of perspectivism save the theory? Does the logic hold?
It saves the internal consistency of the infinite regress, yes. But it is not a safe harbor. Philosophy demands a high price. You don't just get to wave a wand, declare facts are perspectival, and walk away back to the physics lab.
You have to explain how it works.
You have to explain how a perspectival reality actually functions. And to illustrate the immense metaphysical cost of this, Riedel invokes Fine's trilemma, developed by the prominent metaphysician Kit Fine.
Let's explore this trilemma. What are the three principles we are forced to grapple with?
Fine's trilemma was originally formulated to deal with the philosophy of time, but Riedel brilliantly maps it onto quantum perspectives. The trilemma demonstrates that if you adopt perspectivism, the belief that literal facts only obtain from specific perspectives, you must sacrifice at least one of three deeply entrenched, highly intuitive principles about reality. You cannot keep all three.
What are the three principles?
Number one is neutrality. The principle that there is no metaphysically privileged perspective. There is no ultimate God's eye view that is more real than any other.
Okay, neutrality.
Number two is coherence. The principle that reality is fundamentally coherent and does not contain contradictory facts.
Coherence, got it.
Number three is absolutism. The principle that the constitution of reality, the fact that reality exists at all, is an absolute unconditional matter.
Neutrality, coherence, absolutism. Pick two.
If you abandon neutrality, you adopt a position called privileged perspective realism. You concede that while everyone experiences their own perspectival facts, one specific perspective is the true, absolute metaphysical reality.
But that instantly vaporizes the core philosophy of RQM.
Completely.
The entire point was the egalitarianism of physical systems. The photon, the milkshake, and the human are all equal reference frames. If we suddenly declare that Wigner's perspective is the true privileged reality, we've just reinvented classical absolute physics with a dictator.
Precisely. RQM cannot survive the loss of neutrality. That leaves two much darker options. What happens if we abandon coherence?
To abandon coherence is to accept that reality itself contains fundamental contradictions, right?
Yes, and this leads to a metaphysical framework called fragmentalism.
What does a fragmentalist universe actually look like?
Under fragmentalism, reality is not a unified whole. It is fractured into various internal fragments. Inside the friend's fragment of reality, her facts are perfectly coherent and logical.
And Wigner?
Inside Wigner's fragment, his superposition math is perfectly coherent. But if you hold the totality of reality together, the fragments mutually contradict one another. Reality is a shattered mirror, and the pieces are fundamentally incompatible.
How does physics even operate in a fragmented reality? If the overarching structure is contradictory, how do systems interact?
That is exactly the open question that makes fragmentalism prediction at the universal scale. And if you refuse to pay that price, if you insist on keeping coherence, you are left with only one remaining sacrifice. You must abandon absolutism.
The idea that reality's existence is absolute. If we abandon that, what do we become?
You fall into external relativism. This is perhaps the most difficult concept to grasp. It argues that the very existence of reality, the constitutional makeup of the universe, is a perspective-dependent matter.
So reality itself.
Reality does not just exist as a container for events. Reality itself only obtains relative to a standpoint.
Reality is conditional.
Yes. And here is where Riedel levels his final, most damning critique of the physics community. Quantum relativists, including Ravelli and his contemporaries, use the phrase relative facts casually in their physics papers. They use it as a mathematical get-out-of-jail-free card for paradoxes.
Just to make the math work.
But they haven't done the philosophical homework. They assume the philosophers will clean up the mess later without realizing that the cleanup requires adopting either fragmentalism or external relativism.
They are writing checks that their metaphysics can't cash.
Exactly. And the situation is exponentially worse when you remember that classical RQM still requires the unrestricted iteration principle.
Oh no.
If you embrace perspectivism and you embrace the infinite regress, you are now positing an infinite sequence of perspective dependencies. A fragmented reality inside a fragmented reality inside a fragmented reality infinitely.
The mind physically recoils from trying to picture that.
And that cognitive recoil is exactly what the famous philosopher Hilary Putnam warned against when discussing extreme relativism. Putnam argued that at a certain level of iterative relativity, our grasp on what the position even means begins to wobble.
Wobble.
Yeah. If a perspectivist says it is a fact that it is a fact that it is a fact that the spin is up, the human mind loses the capacity to assign truth value to the proposition. The language loses its anchor to meaning.
So what does this all mean? Let's synthesize this incredibly deep journey. We started with a clean, sharply defined physics problem. Wigner and his friend disagreeing over the state of a spinning atom due to the conflict between unitary evolution and wave function collapse.
Right.
Carlo Rovelli steps in with a beautifully elegant, mathematically parsimonious solution. Eliminate absolute facts.
Yeah.
Make every property strictly relative to the observer involved in the physical interaction.
The math works perfectly, and it initially appears to be a masterpiece of operationalism.
But Riedel's paper reveals that when you pull on the thread of that elegant physics solution, you drag an absolute dreadnought of metaphysical baggage behind it.
We really do.
To allow observers to communicate and agree on anything, you need the unrestricted iteration principle. That principle triggers an infinite regress of relativity. That infinite regress mathematically destroys the safe, philosophical option of relationalism, forcing the theory out of the master spreadsheet and into the fractured clipboards of perspectivism.
It's a domino effect.
And once you land in perspectivism, Fein's trilemma forces you to literally shatter the concept of a coherent absolute universe into contradictory fragments or conditional realities.
Which perfectly explains the panic of the 2023 update. You can see why Adlam and Ravelli wanted to invent the cross-perspective links. It was an attempt to stop the bleeding.
Just put a Band-Aid on it.
Exactly. To say, look, the flash of interaction is an absolute fact. The spreadsheet is back. Let's just go back to doing physics and ignore the trilemma.
But taking that easy way out means abandoning the radical insights that made RQM revolutionary, and it invalidates the very Wigner's friend paradoxes that justified the theory in the first place. You can't have your cake and eat it too.
No, you can't.
You either embrace the infinite fragmentalist abyss, or you go back to classical absolutes and find a different, likely more convoluted way to solve Wigner's friend.
Riedel is forcing the physics community to stare directly at the price tag of their philosophical assumptions. You cannot rewrite the ontology of the universe to solve a math problem without paying the metaphysical toll.
For you, the listener, whether you are a working physicist dealing with density matrices or just an intellectually curious mind fascinated by the fabric of reality, this debate hits incredibly close to home.
It does.
It forces you to interrogate what you mean when you deploy the word fact in your daily life. When you encounter someone with a radically different worldview, how do you intuitively process that disagreement?
That's the real-world application right there.
Do you act as a relationalist, assuming there is one master absolute spreadsheet and the other person simply has corrupt data in their column? Or do you intuitively lean toward perspectivism, accepting that they operate with an entirely different clipboard, living in a fragment of reality where their facts literally obtain, even if they explicitly contradict yours? RQM takes our everyday human friction over truth and magnifies it to the foundational level of matter itself.
It is a stunning realization that the most advanced theories of particle physics eventually circle back to the oldest questions of human epistemology.
Which leads me to a final, slightly terrifying thought to leave you with, directly lifted from footnote 23 in Riedel's own text. It's a provocation for you to mull over as you go about the rest of your day.
Oh, this is a good one.
Think about your own consciousness right now, the subjective, undeniable experience you are having, synthesizing this deep dive. Your mental states, your feeling of understanding are intimately tied to the physical state of your body, your neurons firing, the chemistry of your brain. But under classical RQM, your body only possesses physical states relative to an infinite sequence of other systems. Your neurons only exist in a determinate state relative to the surrounding tissue, relative to the air in the room, relative to the planet.
Which logically implies...
Which implies that your very experience of consciousness, the feeling of I am here, existing and listening, is itself merely a relative phenomenon. Are you only having this subjective experience relative to an infinite sequence of relata? Is there any absolute objective fact in the universe that you are feeling anything at all right now? Or is your very mind just another relative flash in an infinite hall of mirrors, obtaining only from a local perspective?
That is a lot to process.
Think about that the next time you drop an anchor, expecting it to hit the sea floor.
Hmm.
Because down in the quantum depths, the water really does go down forever. Thank you for joining us on this intense exploration of the source material. We'll catch you on the next deep dive.